So this is TIA Programming 1 and Chapter 6, um, Program Blocks and Program Editor. So in this chapter, um, in this chapter, we will learn about program blocks and the program editor in TIA Portal. Program blocks are the core of PLC programming. They allow us to organize logic, control processes, and structure our automation system efficiently. We will also explore how cyclic execution work, how to create and manage block, and how to compile, download, and monitor program inside CPU. Moving on. So as you can see, this is a conveyor model that work as a distribution conveyor. So in this section, the conveyor motor moves item from one point to another in automation terms. The motor is our actuator and it was controlled by a PLC output. The PLC reads signals such as the S right and S left. So if we press S right, it will go right. If we press left, it will go left. And it will process the logic inside program blocks and control the motor accordingly. So program blocks, there are many types of program blocks. As you can see, this is a function block, and the function block is inside an OB block. So we will talk about that next. So this is the type of program block. In TIA Portal, there are different types of program blocks. First, we have OBs or organization blocks. These OBs control the execution structure of the program. The most important one is OB1, which runs cyclically. Second, we have FCs or function. Function contains reusable logic but do not store internal memory, while function blocks or FB are similar but can store data in an instant data block. So you can see this is function. Function is on his own, while function block has a data block where it can store data inside of it. Each block type serve of different each block type serve a different purpose in structure programming. Speaking of structure programming means dividing a large program into similar organized block. Instead of writing everything inside OB1, we create a separate function for specific tasks, such as a motor control, sensor handling, and alarm. This improves readability, troubleshooting, and reusability. It also makes the program more professional and scalable. So as you can see, there is type of structure program. First is linear program, which all instructions are found in one block, the organization block. Then we have program partition into areas. So the instruction for the individual function are found in individual blocks in OB. And the OB call this block one after the other. Next, we have structure program, which is a reusable function are programmed in individual blocks. OB cycle calls this block and pass the relevant data. Next, we are going to look at process image. Process image are memory areas where input and output signal are stored during program execution, which at the beginning of the cycle, the PLC reads all the physical input and store them in the input process image or PII. And during the cycle, logic operates on this stored value, and at the end of the cycle, the output process image, the PIQ, is written to the physical output or the output module. So this is how cyclic program execution works. The PLC operates in a cyclic manner. First, it reads input. Second, it executes the project logic in OB1 and other call blocks. And third, it updates the output. So as you can see, it will read the input state from the input module and saving the state in the process image, the PII. Then it will call and execute in OB1 and other call blocks. Then it will write the process image output, the PIQ table, in the output module. So now we are going to look on how to add a block. To add a new block, in TIA Portal, we go to Program Blocks, right click and select Add New Block. So you can just right click this and this will pop up, and you can just click this and you can choose the type of block that we want. You can also assign name, and select the programming language like ladder diagram or function block diagram. Each block also has their own properties. We can define their programming language and also see the timestamp to know when the block was created or last modified. This helps in version tracking and documentation. Then we have IEC check. The IEC check ensures that the program follow IEC programming standard. It helps detect error and or inconsistency and improve reliability. Then we have know-how protection. So basically, know-how protection is used to protect IP or intellectual property. When enabled, other user cannot view or modify uh, the block internal logic without a password. So basically, it's a password to keep our IP safe. So we have other block attributes. Block also have additional attributes that control their behavior and accessibility. These include memory behavior, accessibility level, and execution setting. So this is the block editor settings. The block editor setting allow us to customize the programming environment. You can adjust the layout, the display option, and even the programming preferences. Next, we are going to look on block network. So logic inside the block is divided into network. So as you can see, there is network 1, network 2, and network 3. You can add network just by press this insert network. Each network represents a separate logical section, making the program easier to read and debug. Then we have block programming. Block programming involves inserting instruction like context, which is this one, and coil, timer, and even counters. This is where we implement the actual control logic. So programming using an instruction using an programming using an empty box. The empty box allows us to manually type an instruction name. Instead of just dragging it one by one, we can just type the function name directly for faster programming. Next is how to close, saving, and reject a block. After editing, block can be saved, closed, and rejected. Saving keeps the change, while rejecting cancels the modification. Then we can also add a group to make it more tidy. Block group are used to organize block into folders, help manage large project with many blocks. So if you have if you use if you have a large project that use many block, add them into a group will help you manage all the blocks easier. Then we also, if we want to use that block, if we want to use or execute the block, we must call it first. It must be called inside another block, usually OB1. So basically, if we want to use this function, like function conveyor motor, first we need to drag it or call it simply just by dragging it into the OB1. If you don't call it, it won't run. OB1 will be the one that executes it during every scan cycle. Next, we are going to talk about compiling a block. So after you make all the logic inside the network and all, the best thing you need to do is compile. Because compiling checks the program for errors before downloading. So it will ensure that there are no syntax or configuration errors. So if we don't compile, we won't know if there's an error in our program. So it was advised to compile it first before downloading, so there is no error and it will download successfully. So as I said before, if we want to download, after we must compile it. After compile, the program will download into the CPU if there is no error, and it will run, and the CPU will now run the updated logic. Okay, about the S7's 1500 CPU, it uses a specific memory concept to manage a program and data storage. So it will separate load memory, work memory, and retentive memory for efficient execution. Then we can also monitor a block while the CPU is running. Monitoring allows us to observe real-time signal status inside the block. It was used for debugging and testing logic. We also can delete a block. Blocks can be deleted if it was no longer needed. Unused block should be removed to maintain project cleanliness. So, upload block from device. We can upload block from the CPU into the project. It was useful when retrieving program data from an existing PLC. Blocks can also be compared. Block comparison checks difference between offline and online version. It will help verify whether the CPU program matches the project file. So this is the symbol and the symbol of the status and its meaning. So as you can see, the first one is folder contain object whose online and offline version are different. The second one is the comparison result is unknown. The third one is the online and offline version are identical. The next one is online and offline version of the object are different. The next one is object only exists offline, and the last one is object only exists online. So by looking at this symbol, it will help us identify the meaning, the status of the the CPUs. Okay, now I'm going to show you briefly. I want to show you a brief demonstration on how the FC and FB works. So as you can see, I'm using 4 FB in one main OB. This is the OB1, which is you can say it's the manager, or because OB is the one that controls the execution flow of the PLC. It tells the PLC when and how to run the program. So basically OB1 runs you can think it of a manager that start everything. All right, so we have function. Function is a block that contains reusable logic. FC does not store memory because it doesn't have an instant data block, not like FB. FB is almost the same as function, but the difference is FBs they have their own data blocks, so they can store their memory. You see, you can put your own memory, and yeah, when you call it, you can put your own tags, so it will be much easier. So as you can see, I have 4 different function blocks. Each function block has its different programming or different logic. So right now, what I'm going to show you guys is the FB for R-axis motor. So basically, I have a mini crane model that can move up and down, in and out, and also rotate. So right now, what I'm going to show you guys is the rotation part of the crane. So I'm using an FC to check whether the whole actuators are in the home position. Otherwise, it won't allow us to move, to run the program. So as you can see, every single actuators are in their home position, and it will give us the information that all actuators are ready and safe to run. All right, going back, we can just monitor these two and see. All right, so right now, again, I put it here too to show you guys that they are in its home position. So right now, we can also monitor inside of a function block. So right now, as you can see, counterclockwise will start the counterclockwise motor. So it would move counterclockwise. But right now, since it was in home position, it won't start, all right? Unless I start the clockwise motor, make the motor turn clockwise, then it will turn. All right, it will turn. All right. So let me show you guys how it worked. So what I need to do is just press this, right? So now it'll no longer in home position. It was turning, but it will stop until it hit the proximity sensor. So now, yeah. So the motor is no longer running in clockwise because it hits the limits. So right now, the proximity sensor is the proximity sensor is um, it's not letting the motor to continue going counterclockwise because it was the limit. So there is no other choice than to go counterclockwise. Then if we go counterclockwise, then it will also won't go too far. It will stop until it hit this limit switch. So let me show you. So just simply counterclockwise. So as you can see, it's no longer hit the proximity sensor, but it hit the limit switch. So now the counterclockwise, the motor doesn't run in counterclockwise anymore because it already reached the home position of the 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 motor. So I guess that's all for the demonstration. Thank you very much.